Today we're one step closer to the definitive cure for alopecia. And no, I'm not talking about PP45 or GT20029, but a solution I've discussed on my Spanish channel several times, which until recently felt like science fiction: hair cloning. And we have some truly major updates on this front. Imagine what we could achieve if we could clone healthy terminal hairs from anyone with alopecia. This means that no matter how advanced your hair loss is, there would be a solution. You could clone just one of the healthy hairs and simply graft the cloned follicles into the bald areas of your head. It would be the end of baldness. Well, as long as this treatment is affordable for everyone, of course. To understand the magnitude of what we're talking about, you have to realize that hair cloning has been the great unreachable goal of medicine for over 2 decades. It's not that people haven't tried, it's that biology has repeatedly pushed back. In the early 2000s, companies like Integrin in the UK were already promising that the cure was just around the corner. Their idea was simple: extract dermal papilla cells, multiply them by the millions in a lab, and re-inject them. It seemed like the perfect plan, but in 2008 they had to admit failure in their clinical trials. But what was the problem? As soon as the cells were removed from the body, they lost their identity and forgot to produce hair. They were cloned hairs, yes, but they were biologically dead for their intended purpose. Then came the Japanese giant Integrin, which spent nearly $100 million over 10 years trying the same thing. They reached phase 2 clinical trials, but in 2013 they stopped the research because the results weren't better than a standard hair transplant and the costs were astronomical. It seemed as though hair cloning was cursed, and it was impossible to maintain the potency of those cells outside the scalp. And this is precisely why the latest studies on hair cloning are so revolutionary. After 20 years of hitting a wall, we have finally found the exact markers and a specific group of cells that allow the follicle to keep its memory. We've moved from trying to revive tired cells to manufacturing brand new organs with their full regenerative capacity intact. To understand the latest study published just a few days ago, we first need to talk about another study from 2021 performed on mice. This study, led by Takashi Tsuji's team in Japan, truly laid the foundation for modern hair cloning. You see, the big problem with cloning until then wasn't just cloning the hair itself, but ensuring that the cloned hair went through the normal growth phases: anagen, catagen, and telogen. Until then, the issue was that cloned grafted follicles would burn out and die quickly. The researchers discovered that the secret to infinite regeneration lies in a very specific group of stem cells located in the bulge. Be careful not to confuse this with the bulb, which is the base of the hair. The bulb is the factory that creates the hair shaft, but it disappears during each growth cycle. However, the bulge is located higher up. It's a permanent zone that acts as a warehouse for stem cells. Within that bulge, they found a marker called Integrin Beta 5. They detected that if you cannot isolate and multiply these specific cells in the lab, the graft is doomed to fail. Without them, the hair grows once, and when it reaches the shedding phase, the follicle forgets how to grow again. The most important part of this study is that the researchers achieved 2 things that completely changed the paradigm. First, a culture method that multiplies these cells 200 times in just 6 days, an incredible speed for commercial production. And second, 80% of the cloned hairs in mice successfully completed more than 3 growth cycles. In other words, the grafted cloned hairs weren't lost, they grew just like normal hair. And even though we're talking about an animal model, the team verified that humans also have this Integrin Beta 5 marker in the exact same spot of the follicle. Basically, this study proved that the battery for the cloned hair to stay alive and grow through the normal growth phases exists, and we now know how to recharge the battery in the lab. Now it's time to talk about the latest study published only a few days ago, a study also led by Takashi Tsuji. This study conducted on mice tells us that having the right stem cell isn't enough. For cloning to become a reality, the hair must be capable of what scientists call downgrowth, the biological force that makes the follicle sink into the skin to anchor itself to grow with strength. This is where the second study changes the game. Researchers have identified a third type of cell, hair organ's intrinsic mesenchymal cells. Until now, cloning attempts only use skin stem cells and dermapapillary cells, resulting in weak hairs that barely grew. By adding this third group of cells, they have enabled the follicle to create its own connective tissue sheath, or CTS. What this means is that they have manufactured a follicle with muscles. These new cells express contraction and actin genes that allow the hair to move, sink into the dermis, and most importantly, complete the regeneration cycle all by itself. They have shown that with these three specific cell populations, the follicle doesn't need external help. It knows exactly when to grow and when to rest. Obviously, this is not a human trial yet, so it's not time to publish in pain just yet. However, these findings are truly encouraging and paint a very hopeful picture for the next decade, where hair cloning might not only become a reality, but also become affordable for everyone. As we've seen, Tsuji's team findings are key to making hair cloning a reality much sooner than many imagine. Furthermore, technically, it could be a process where the commercial production of these cloned follicles is quite fast. I know exactly what you're thinking. This is all great for mice, but when can I clone my own hair? If we look at the typical timelines in regenerative medicine, it usually takes between 5 to 10 years for a treatment like this to reach the general market. Tsuji's team has already stated that their goal is to move to human clinical trials as soon as possible. If the results we've seen in the lab are replicated in humans without side effects, we could be looking at the first authorized clinics around 2030 to 2032, likely started in Japan and then moving to the rest of the world. But beware, two factors could speed up or slow down this process. The first is regulation. If it were considered an urgent treatment due to the psychological impact of hair loss, the timelines could be shortened. But let's be realistic, that is unlikely to happen. The second factor, as always, is money. Initially, hair cloning will not be cheap. Keep in mind this isn't a 6-hour surgery. It's a process that requires high-tech labs culturing your cells for weeks. In the early years, it'll likely be a luxury treatment, similar to the cost of the first hair transplant or modern gene therapies. But the good news is that the biological wall has finally been torn down. We're no longer waiting for a miracle, we're waiting for the first clinical trials to succeed and for bureaucracy and industrial production to catch up. The cure for alopecia is no longer a question of if it's possible, but when it will arrive and when it will be affordable. Obviously, we can just sit around and wait for this cure to arrive, because our alopecia can continue to progress and will keep losing hair. That's why the best thing you can do is to use the most effective and safe treatments we have today, such as Finasteride, Dutasteride, and Minoxidil. If you're afraid of using Finasteride or Dutasteride due to potential side effects, I've just published the most comprehensive book on this topic. It will answer any questions you may have and help you make an informed decision. I'll leave the link in the description. And if you want to know which is the most promising drug in the fight against alopecia, you have to watch this video.